Okay, we're on problem number, what problem are we on here? Oh, number 13, right? So 13 looks like a much more difficult question. It's a clock question. We've done these before. I'm familiar with these, but this is a more difficult one. And that's typical of Wells's. Work gets more difficult as I read on. And it goes, the clock has an hour hand, a minute hand, a second hand, all turning on the same center. Well, that's true for clocks. It says at 12 o'clock, all the hands point to 12. That's true. How many seconds will it be before the hour hand is between the other two hands and equally distanced from them? Boy, that looks like a tough question, but at least I know what the question is. T is in seconds. And I don't know that. So seconds. How many seconds? I have no idea. I have no idea how many seconds are going to happen. But I'm going to write down the rates of the hands. And the rates of the hands, let me write this over here. The second hand does one revolution every 60 seconds. The minute hand does one revolution every 3,600 seconds. The hour hand's going to be tough. And I'm going to use a calculator. So it's going to be 1. It takes 12 hours to do that, by the way. And there's 60 minutes in every hour and then 60 seconds. So I'm going to get my calculator. I'm going to use Sage. And someone says, why do you use Sage? It's put in my notes, and I recommend you do it too. And I'm going to do 12 star, and I'm using my calculator. I'm getting tired, and that's going to be 60 squared, right? And what number do you get? 43200. I'll write that down. So what am I going to do now? I'm going to do the distance, which is revolutions, by the way, between the hour hand. And by the way, I'm not saying the pictures are accurate. I just need a visual aid. So this is the hour hand here, and this is the minute hand over here. And I want to get this distance over here. Well, the minute hand's clearly ahead of the hour hand, so it's going to be 1 over 3,600 t minus, and it's going to be in revolutions, by the way, 1 over 4,3,200 t. Well, that's not so bad. Here comes the tough one. I got the hour hand here. And the second hand's going to be over here somewhere. By the way, I'm not saying these pictures are accurate, but I want this angle. And the reason I want that angle, this angle here is the same as this one over here. But I got a tough time doing that. So what I can do is I can actually do this distance here. Right? Let me outline what I mean by that. I can do this one. It's easy for me to do that. And what's that going to be? Let's take a look. And I got to do that, don't I? So that's going to be, let's see, 1/60th of a t minus, let's see if I'm writing that down right, 1 over 4,3,200 t. But I didn't want that. I wanted the other guy. And let's talk about that other guy now. The other guy here, I wanted this one, is going to be 1 minus that number, because 1 is 1 revolution. So let me write that down. So it's going to be 1 minus this number here. 1 minus 1 over 60 t. Whoops, didn't mean to do that. And minus a minus is plus 1 over 4,3,200 t. And what do I know? I know that this is equal to this. What I want to do is I kind of, work through the problem. I'm not saying I'm going to have a tough time solving this or not. It doesn't look too easy to do, but I think I can handle it. And what I mean by that is I'm actually going to use a calculator, and I'll go through that step by step for you. And I'm using a calculator. But want to see if I've got this stuff written down, and I'm going to go through it for you just by reading it. TB, the number of seconds it takes. It goes on to say the rate of the second hand is this, the rate of the minute hand is this, the rate of the hour hand is this. And then I want to see if they got the equation that I say I got. And I'm seeing it. I'm seeing this, I'm seeing this, and I'm seeing this. All right? Hope you're seeing the same thing, equal, right? I'm going to solve the equation. And for someone to do that, someone says, how do you do that? And again, maybe I'm a little tired right now. I'm at the 13th problem. I get tired. I use a calculator, and I hate to say it, but I'm going to start doing some things here, all right? So the one thing I want to do in doing the problem is I want to start doing some of the arithmetic for you. And the way I'm going to do this is I'm going to do left side, right side, and I want to do the arithmetic. So it's going to be 1 minus something times t. And this over here is going to be somethings times t. Now someone says, can you do the arithmetic in your head? Of course I can, but the problem is I make mistakes, and especially when you get tired, you make a lot of mistakes. So I'm going to be using Sage to do it, and I'm going to do the right side. So that's 1 divided by 3600. Please do not use decimals. Minus 1 divided by 43200. And that gives me 11. I'll write that down for you. Over 43200. I'm going to do the other side, which is, let's see, 1 divided by 43200 minus 1 divided by 60. I'm actually using a computer, and that gives me minus 719 over 43200. I use a calculator to do that. There's no shame in that. And 1 would equal, well, I think I can do that. 43200, this is t. 719 plus 11, that's going to be 730, right? I think I can do that too. And you're going to get 1 equals 73 over 4320t. And I think I know what t is now. What's t going to be? 4320 over 73. By the way, that's a really nasty number, and that's going to be seconds. I'd like to make sense of that, because I'd hate to say that to somebody. Oh, it's 4,320 divided by 73 seconds. I want to get a better feel for it. So I'm going to use my calculator. You may be surprised by that. And I'm going to use, like like what some people call a div mod. And I'm going to put this over here. 4, 3, that's 20, right? And I'm using a div mod operator. On my calculator too, by the way. I got 59. That's how many times it goes in. And let me do my the remainder part now. And let me see if I can do that in my calculator. And you're going to learn a lot by using a calculator. And I'll see if I can do that. And I get 13 over 73. I would much prefer to see this answer over here. So it takes roughly a minute for that to occur, all right? Again, you may want to play around with the clock and just maybe watch the clock do that. And it's going to be about a minute after it starts that you're going to see that happening, all right? All right, thank you so much. This was a tough problem. I did resort to using a calculator, and I do that on occasions. Thank you.